physics to determine the origin of the chemical elements. We observe stars, we know what goes on in their center, they explode, laying bare their contents. And what we have discovered is that the elements of the periodic table, that which we are made of, derive from the actions of stars that have manufactured the elements, exploded, scattered their enriched guts across the galaxy, contaminating or enriching gas clouds that then form a next generation of stars populated by planets and possibly life.
Are we alone in the universe? No one knows for sure, but our view of the universe has changed drastically in the past century. Current estimates suggest that there may be as many as 2 trillion galaxies in the observable universe. The Milky Way alone contains 400 billion stars and at least that many planets. Based on the latest data, there are at least 10 times more galaxies than previously thought and about 100 million stars in an average galaxy. This means there could be as many as 200 quintillion stars in the observable universe. This has quite profound implications for life as we know it. For life to exist, the first requirement is a universe with suitable molecular building blocks. Except for hydrogen, the elements that make up organic molecules are all produced in the cores of stars. We have one example of life in the universe, here on Earth. Its resilience has allowed it to spread to nearly every environment on the surface of our planet. Scientists are trying to use what we've learned about the Earth and its extreme environments, as well as the conditions on other solar system worlds, to understand the connection between the environments of other planets and moons and their potential life forms. So far, the only life we know of is right here on our planet Earth. Yet there are compelling arguments to suggest that we are not alone. Indeed, most astrophysicists accept the probability of life existing elsewhere in the universe. Scientists don't really have a universally accepted definition of life itself. However, the quest to find life elsewhere is ongoing.
If you look at the chemical ingredients of life itself, you remember from biology class, we're mostly water. And good old water is H2O. 2 hydrogens, 1 oxygen. And if you could look at the sort of the element budget of life, hydrogen is number 1, as expressed in the water molecule. The number 2 in the human body is oxygen, turns out. Number 3 in the human body is carbon. 4 is nitrogen. So you go into the universe, number 1 ingredient in the universe is hydrogen. That was true in life. Number 2 ingredient in the universe is helium. Well, because helium is chemically inert. You can't do anything with it even if you wanted. Next in the universe is oxygen. Next, carbon. So we are 1-for-1 matchup with the most abundant ingredients in the universe. Of these, carbon is the most chemically fertile element in the entire periodic table. You can make more kinds of molecules with carbon than all other molecules combined. So, if you were going to experiment through the forces of nature with complex chemistry, and you had to pick an element to base it on, carbon is your man. Given what carbon is capable of doing, perhaps we shouldn't be so surprised that there's life, because we're just another one of the things carbon has rolled up its sleeve. Maybe life is inevitable, given the abundance of carbon and oxygen and nitrogen and hydrogen in the universe.
There are thousands of exoplanets that have been confirmed to exist in our galaxy, and the likely number could be in the trillions. With the discovery of a growing number of exoplanets, astronomers consider the possibility of finding extraterrestrial life. However, they are not quite sure whether a planet even needs to be like Earth for life to occur. The James Webb Space Telescope could get the first glimpses, the mix of gases in the atmospheres of Earth-sized exoplanets. This telescope, or a similar spacecraft in the future, could pick up signs of an atmosphere like our own: oxygen, carbon dioxide, methane. NASA's SETI program is home to more than 100 scientists that conduct grant-funded research addressing questions concerning the existence, evolution, and prevalence of life in the universe. Furthermore, NASA are creating computer models of exotic exoplanet atmospheres based in part on our understanding of Earth's atmosphere and our worlds closer to home: Mars, Venus, Jupiter, and Saturn. and even Saturn's moon, Titan. Should life be discovered elsewhere in the solar system, astrobiologists suggest that it will more likely be in the form of extremophile microorganisms. SETI, however, is also trying to detect evidence of technological civilizations that may exist elsewhere in the universe, particularly in our galaxy. There are potentially billions of locations outside our solar system that may host life. With our current technology, we have some ability to discover evidence of cosmic habitation, and, in the specific case of SETI experiments, to find beings that are at a technological level at least as advanced as our own. Intelligent, technological life might create atmospheric pollution, as it does on our planet, which could make it detectable from instruments that we develop in the future. This pollution, or some other artificial phenomenon, might be detectable on planets orbiting the nearest stars. Signals from the planet itself can also be detected if they are radiated at frequencies from the electromagnetic spectrum, radio, visible, or infrared radiation, although most SETI experiments focus on radio signals because of the greater transmission distance compared with visible light. Presently, the best place to search for extraterrestrial life is in our own solar system. The fact that life was able to evolve here on Earth over a 4 billion year period is strong evidence that life could also evolve elsewhere. Given how long life has had to evolve on Earth, it is possible that there are beings on other worlds that are even more advanced than we are. That would certainly have implications for our understanding of the origins of life. A new study, however, suggests that alien civilizations destroyed themselves through progress, meaning our galaxy could be full of dead alien civilizations. Even here on Earth, of all species of life forms that have ever lived, over 5 billion, more than 99% are estimated to be extinct.
We think very highly of ourselves. We call ourselves intelligent. We list things that we do that no other animals can do. So we say, oh, we have poetry and philosophy, and we have the Hubble telescope, and we compose symphonies. We're intelligent. That is our measure. All right. Well, I studied this briefly, and you ask, well, what is the next closest species to human beings? Basically the chimp. And how much DNA do we have in common? It's like 98% identical DNA. So we are convinced that whatever is in that 2% is significant. But I want to pose to you a disturbing thought. Maybe the difference in our cognitive capacity, maybe that difference is as small as that 2% suggests. Maybe the Hubble telescope and our greatest of operas and music and poetry is not much different from stacking boxes and reaching a banana. Imagine a species 2% beyond us in the same scale in which we are 2% beyond the chimp. How smart would they be to us? If they're as smart compared to us as we are to chimps, then to them there'll be no difference between stacking boxes and the Hubble Space Telescope, because they'd be capable of mental feats far beyond anything we could possibly conceive.
It seems we're at the dawn of a new chapter in human history. Given the current pace of innovation and how fast technology advances, it is entirely possible we could find life elsewhere, within the life of the present generation. Given that we do not know what kind of life we might find elsewhere, we should look at how life has evolved on Earth to help us understand what we might expect from other living beings on other planets we discover, if we ever do. With a limited understanding of how life originated on Earth, and with so little understanding of what kind of life there is elsewhere in the universe, it is not too surprising we don't know what we're going to find out there, but it seems very likely that other life will have developed in different ways to that which evolved on Earth. The diversity of life on Earth and the different types of environments it exists in has much to teach us about how life might have started. So, are we alone in the universe? As Arthur C. Clarke has pointed out, two possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying. Thanks for watching. Did you like this video? Then show your support by subscribing, ringing the bell, and enabling notifications to never miss videos like this.